Hi everyone, welcome to this new series for So Java. Now we are running the Java at Cloud Age series, and today I'm very happy to have with us here. Let me just mute my my other session here. So we have here today our good friend, Mr. Ruslan Sinitsky. I've been training your name the whole week, so I won't miss your name. It's correct, Sinitsky?
Yeah, exactly.
Yeah.
It is correct. Yeah.
Okay, perfect.
Just Ruslan is more easier, like
Ruslan, yes.
yeah, unique
So
name, like easy to remember.
yeah. So Ruslan is the CEO of Jelastic, a very known company. So Ruslan, thank you very much to be with us here today. It's a pleasure, and the word is with you right now.
Elder, thank you very much for invitation, and it's a pleasure for me too to talk about Java in the cloud, about modern improvements, recent improvements we got in OpenJDK. So I'm excited and looking forward to to deliver some knowledge about technology and a little bit about business as well because it's important, and even to do the live demo. So I expect to get some kind of live conversation because it will be more interesting for both parties, right? For participants and for me as well. So if you have any questions, feel free to ask, and yeah, I will try to answer immediately. Yeah.
Great. I will monitor the chat. So if you guys are here, can send any questions to Ruslan, just write on the chat. I will say to him. Okay.
Good. So let's start.
Yeah. Awesome.
Great. So today we will talk about elasticity of Java in the cloud and in containers. And I would love to use this opportunity for two messages. One of them, of course, about technology, how we can improve the technology and how we can use these recent improvements for ourselves. And second, I would like to show an example, and I hope to make some kind of inspiration for people to aim bigger goals. Because what happened recently is very interesting situation, and because one person had a dream, we have better Java now. So what I mean specifically, in the recent update of OpenJDK, we got an improvement. I will share my screen so it will help to get a better understanding of the material. So recently we got very interesting improvement for G1 garbage collector that enables uncommitment of unused RAM back to operation system. And it's very important for density and for saving money in the cloud. Because if you save money, you can spend this money on your team or on extension of your project or to buy just more resources. So let's go through the presentation. So today we will talk about vertical scaling of Java heap inside containers in the cloud. And we know that Java can be greedy. It can consume a lot. So we have a lot of jokes about Java memory consumption. And specifically in the past, in 2011, I personally faced this problem when I was working for a small startup. We had very limited budget, and we were using Java. I was looking for a Java hosting, and I was not able to find a good Java hosting. And later, I had an opportunity to talk to service providers, to hosting service providers, why they do not offer Java. And the answer was very interesting for me. First of all, they told very well-known issue that Java consumes a lot, and it costs a lot for end customers at the end. And Yeah, and customers, specifically small customers, are not ready to pay for it, like startups, and so they choose another kind of languages. Like at that time, PHP was very popular. It's still very popular because it's easy to start for smaller projects. So that was number one problem. Again, like in hosting industry, it was very difficult to offer cost-efficient hosting. And second problem, it was related to complexity of Java. So Java itself is not simple, let's say, right? It becomes more simpler. But to manage a lot of Java environments, it's hard. You need to have understanding how to do this. So, but it's another kind of problem. We decided to solve this problem specifically with Jelastic. So Jelastic means Java Elastic. So we put our efforts, we put our money to solve specifically this elasticity problem, to make Java more efficient in terms of resource usage and in terms of money for hosting. So what kind of benefits we get if Java becomes more elastic? Everyone knows elasticity in terms of horizontal scaling. When your application gets more requests, more end customers, usually people spin up more VMs or more containers. And it's very good approach. It's very good for availability and for performance. However, there is a hidden issue. If your virtual machine or container is not optimized, and specifically Java process consumes a lot of resources, you will scale horizontally in efficiency. So during the scaling, you will pay more and more. And that is not always good. So this is the one problem. Horizontal scaling of inefficiency. And second problem we face still today, by the way. So when you want to increase or decrease heap that Java virtual machine uses, it's impossible to do on the fly. Nobody was thinking too much about this in the past, to be honest, because like Java was, running on premise a lot. People already bought servers, so they don't care if there is some unused resources because they already paid for the servers, right? And now in the cloud, let's say if you bought a virtual machine, you pay always for this limits of virtual machines. So it does not matter if your Java virtual machine, consume all these resources. But when containers came to the stage, situation changes because containers are more elastic by default. So they can be resized on the fly, they can share unused resources with other containers on the same host. But Java is not ready for these containers yet. Was not ready, let's say. So our goal was to improve this elasticity for OpenJDK, inside OpenJDK. And if you think today about modern environments, about Kubernetes, let's say, right? Like everyone likes Kubernetes. How do we run Kubernetes in the cloud? Majority of cloud vendors offer the following model. You provision virtual machines and you run user application pods inside these virtual machines. You can run many containers inside same virtual machine. So if your JVM is not efficient, you will not use this virtual machine in the most optimal way. If you can improve behavior of your JVM, if you can improve memory usage, so you can put more containers inside same virtual machine. At the end, it will help you to save money, to pay less to cloud vendors. So this is the obvious benefit, and we can enjoy it now because with OpenJDK 12, major improvements are available for Java Elasticity. Another additional benefit for making Java more elastic is related to more complex systems. Let's say a big enterprise company or like cloud service provider runs a lot of Java processes, Java virtual machines. Sometimes a service provider needs to do maintenance. Usually, they send notification in advance, like we will do maintenance and we will shut down this node, let's say, right? But more advanced systems allow you to do live migration of virtual machines or containers. And if JVM consumes not very much, it's much easier and much faster to migrate containers from one host to another one. So it helps, again, like to speed up rebalance of load inside large clusters. I would say it's more advanced topic, but still just wanted to mention this one. So coming back to cloud and how we pay for the cloud today, right? There are two models. One of them is pay as you go, and another one pay as you use. So pay as you go, it means you buy virtual machine with specific limits, let's say 16 GB of RAM, and it doesn't matter how much resources you use, you always pay for these limits. So as I mentioned, we still can optimize this billing model to put more containers inside the same virtual machine and utilize this in a better way. Another model, when service providers charge end customers only for real used resources. And it's called like pay per use. We see this model becomes more popular. For example, big cloud vendors introduced this model for serverless already. It's very good. And another example, Java service providers, Jelastic service providers are offering this pay-as-you-use model for standard workloads, for stateful workloads already. And a lot of customers are benefiting from this model. So Java should be aligned with this model, because if Java can be elastic and can give back release resources back to operation system when it's not needed, we can save money at the end. So what are the major blockers, let's say, to make Java elastic? Let's say this is a good example. This image illustration explains the major blockers. There are two of them. So on this illustration, you can see like blue, it's used heap, and orange, it's reserve heap by JVM. So Java can reserve a lot, but it can use very little. However, reserved means used in some way. So it cannot be shared with other processes inside, and it means it cannot be shared with other containers as well. So we decided to solve these problems and improve OpenJDK. By the way, second problem, if you defined max heap from the beginning, it's impossible to change this XMX parameter afterward. So you have to restart Java virtual machine, which is not optimal for in some cases. Maybe it's not needed for everyone, but still, to have such kind of solution will be very helpful and useful. I found a lot of questions on Stack Overflow about how to change XMX in runtime. However, it's still impossible, but I have good news for the community. The work is going on. People are working on this, and it will be solved soon. So we tested all garbage collectors, let's say almost all garbage collectors. And we figure out which garbage collectors are good for containers, which garbage collectors can be scaled vertically. And you can see there is an example of testing G1 garbage collector. So you can see orange line, how JVM commits the RAM, and blue line, how much it consumes the RAM. And as you can see here, at the end, we have a drop. So it means garbage collector, the G1, can release unused RAM back to operation system. However, before OpenJDK 12, it requires full garbage collector. So it requires explicit call of full garbage collector cycle. So you have to explicitly call full GC, which is not very good because, first of all, it's some kind of performance degradation. And second, you need to add extra logic to handle this issue. We tested G1 on different cases when it grows fast, let's say when memory grows fast and when memory grows slow. So in general, G1 is good for elasticity. Yes, the only issue we faced again is full garbage collection cycle. So we solved this problem, and I will show a couple of slides about this a little bit later. Before I jump to solution, let's walk through other kind of options we have. There is a popular option like aggressive heap. It's very good for high performance applications because JVM commits all available RAM immediately, and yeah, it will serve request faster. But if you use this aggressive heap approach, just forget about vertical scaling. Just forget about elasticity. It will not release unused RAM back to operation system. So when to use this aggressive heap and when not to use? Again, like if you go to production and your production application is very loaded and receives a lot of requests, feel free to enable this aggressive heap because money in this case is not as important as quality of your services. If you use development environments or test environment or some kind of variable workloads, then I would not recommend to go with aggressive heap because otherwise you will, if you don't enable aggressive heap, you will be able to save money and resources. So you will be able to put more workloads on the same infrastructure. Another one garbage collector is a parallel garbage collector. Unfortunately, this one is not scalable vertically. So we were trying to solve this problem with already available options, but we did not find any solution. The good news, we have a patch to OpenJDK that improves parallel garbage collector as well. I'm not sure that we want to move forward with this patch because new generation of garbage collectors are coming already. So maybe we can stick to G1 and others and just, you know, in time forget about parallel garbage collector. So I'm looking for a feedback from end users. If you need this elasticity for parallel garbage collector, then we will put more efforts. If not, we will just focus on next generation garbage collectors. Serial garbage collector, which was one of the first, actually can be scaled vertically as well. I will not review benefits of these different garbage collectors because there are a lot of materials already in the internet. I just want to walk through vertical scaling. The issue in garbage collector is this garbage collector releases heap back to operation system in steps. You need to call full garbage collector cycle 4 times before JVM releases all unused RAM to operation system. Same issue with concurrent mark sweep garbage collector. So you need to call 4 times full GC. However, there is an improvement for inside OpenJDK specific parameter which called like shrink heap in steps. So you just disable this shrinking in steps. So your JVM will be able to release immediately after full GC. Release immediately unused RAM back to operation system. So if you are using concurrent mark sweep or serial garbage collector, feel free to enable this option. How we solved the problem before OpenJDK? So as I mentioned in the past, we had a problem with elasticity, and I was dreaming to, to solve this problem. I was talking to different people, and I heard a lot of negative feedback. It's impossible. It's not important, and so on. But I stick to my dream, and at the end, we found a solution. We created agent that we attached on the fly to running processes, and this agent controlled usage of memory inside JVM. And at the time when we saw difference between used and unused RAM was significant, and performance CPU usage was not big, we call a full garbage collector cycle. So we implemented some kind of workaround. And then we pushed this solution to inside our platform, and we gave the solution to end customers and tested this on dev environments and on production environments. And we were happy because we did not hear any negative feedback. So it worked well. And moreover, customers provided great feedback because it just saved a lot of money for them at the end. So we moved forward and reached community and started to talk wider about this problem. I remember at some point I presented this idea at GCP meeting, and I talked to different experts that are working on OpenJDK. And at some point I found a guy, Rodrigo Bruno, who was working in Portuguese university, and he agreed to collaborate on this solution. And he actually had a good knowledge of OpenJDK, and we joined our efforts and we created first patch. Then later, we introduced this patch to other friends, and other experts joined us, and actually Oracle joined us and collaborated on this patch. And what happened, we committed improvement directly to mainstream. So now OpenJDK 12 can handle this vertical scaling automatically. So how it works? We added 2, even 3 parameters that can manage elasticity. The major one is G1 periodic GC interval. So this parameter defines in which interval to call full garbage collector cycle. So you can now define directly through the option and force your JVM to uncommit unused RAM. Actually, the algorithm is much more advanced. It does not call full garbage collector from the beginning. It tries to compact and release unused RAM by calling smaller cycles, not full garbage collector cycle. So which is very good. And I'm very glad that other experts joined these efforts because they had much bigger knowledge how JVM works inside. So they were able to improve initial algorithm very much. So another option is G1 periodic GC system load threshold, which defines if your container or VM is under a CPU load, then do not call any garbage collector. So, and this threshold defines this trigger, let's say. Yeah. So you can define, for example, if there is a big load inside of container, don't do anything. If the load is less than specific threshold, then feel free to release unused RAM. Yeah, and another parameter, G1 periodic GC invokes concurrent, specifies how to call garbage collection cycle, concurrently or not. You can follow to description of this patch. Yeah, and it specifies the reason why we did it, and yeah, specific details of the implementation, and so on. It's already available inside OpenJDK 12, but as I know the work is going on, there are some additional improvements were recently introduced inside OpenJDK as well. Good. And next one that I would like to highlight, very important, new generation garbage collector, Shenandoah, which was created by Alexey Shipilov, who is my friend. I was talking to him at the beginning. Actually, he was one of the first guys that I shared my idea about this Java Elasticity. It happened in 2011. At that time, unfortunately, Alexey was not focusing on garbage collector. He was doing another kind of job. But later, I believe our talk helped, let's say, him to understand the problem and the need, and he designed new garbage collector in the right way related to elasticity. So it's very elastic. It scales down automatically. It works very fast. I'm very happy that we got this new garbage collector. I will show a demo how it works later. So, but in general, you can follow the link and review this garbage collector at the wiki page. It specifies how it works, different kind of parameters, and so on. I will highlight the major parameters related to elasticity. Yeah, actually, you can see them here. So first of all, you need to unlock experimental VM options. Then you need to specify that you want to use Shenandoah garbage collector. And you need to specify the heuristic for garbage collector. Just define compact, and it will compact automatically heap. As I mentioned, again, it's very good for dev, test environments, and for production that have variable load. Next, garbage collector, which is coming, ZGC. It's very promising garbage collector because it's designed to handle large heap, even like multi-terabytes, and work is going on now. So it's very, very hot. I believe it's still not released, but I'm following conversation inside OpenJDK group, and it's very hot. So people are committing right now. Even yesterday, it was a new commit related to elasticity of Java. So please, if you can, follow conversations. Maybe you can even contribute your opinion, your use case, or you can test this. You can do early tests, let's say, and provide you feedback, which will be very helpful at this stage. One more player on the market, OpenJ9, which is alternative implementation from IBM team, actually Eclipse team now, yeah, because it was contributed to Eclipse. And this team introduced specific parameters to make JVM elastic. And why they did it, by the way, there is a good video which explains the reason why actually the team did it. So, and the reason is because some service providers started to offer pay-per-use model. So JVM should be adopted to this model to save money to and customers. So there are major parameters that influence vertical scaling inside OpenG9. You can follow the link and review later after the webinar. So we were talking about uncommitting unused RAM back to operation system. But what about changing heap on the fly? The answer, it's possible now. Unfortunately, it's not available yet in mainstream. However, there is a patch which was created again by Rodrigo Bruno in collaboration with Jelastic team. And moreover, there is an active conversation about soft max heap size. It's another flag. So there are two kinds of possible implementations, and we are discussing which one, let's say, better for specific cases. So as I mentioned, it's very hot conversation. Feel free to join us and contribute to the community. And your feedback is important. As I mentioned again, like one person can change the world, right? A dream of one guy can influence many other people in the world. So please do not afraid and join the conversation. So at the end, as I mentioned, community realized the importance of this movement, and we won Duke Chase Award last year. I'm very proud of our work and work of all people who contributed to this work. So it's general achievement. It's, I mean, achievement of joint efforts. So now I can show demo how it works in reality. But before I jump to demo, maybe there are some questions already, guys.
No questions so far in the chat. No specific questions. So I think you can go ahead. Okay,
no problem. So as I work in Jelastic, I will show how it works inside Jelastic, because actually it's the most advanced in terms of elasticity for Java. So I will show how it works. Before demo, I created two environments, one of them with OpenJDK build and another one with Shenandoah. It's quite easy to do. How I did it, I just switch to Java tab and go to Java engine, right? And I can choose different options of OpenJDK, different versions. I would like to choose, let's say, 12 build. Yeah, and just print the name to test. Yeah, and define limit, how much I want. Let's say I want 2 GB for this. Yeah, for this container. I create container. And same you can do for Shenandoah, but a little bit in different way. Let's say I want to create Shenandoah OpenJDK via as a Docker container, let's say. So I just print Shipilov. Yeah, and you can see there is a Shipilov OpenJDK Shenandoah container image. So I choose this one, yeah, and I just choose latest version. Again, 2 GB of RAM as well. Yeah, and just press button create. In a couple of minutes, we will have 2 environments. Yeah, but to save time, let's jump on already pre-provisioned environments. So I have 2 containers. In one of them, I will show how the Java is flexible, and another I will show how it's not. So to run the test, we have very simple application, vertical scaling here. It's available in public repo. So you need just to download this application, right? And inside your container, I have here already, up jar, you can see. So, and then I just run the following command. So as I mentioned, I specify XMX as 2 GB, and then I specify a threshold for CPU load, for example. If CPU load will be higher, I mean, like load average will be higher than 0.6, uncommitment will not happen. And I specify period for periodical garbage collector. You need to specify this in milliseconds. This is why you see 3K. So it means 3 seconds. And then I just defined minus jar up.jar. And 1, it's a parameter for application, how fast to load memory. 1 is quite fast, 10 is medium, 100, it's very slow. Yep. So let's start the test. We press enter. And in a second, we will see the following data. Initial RAM is 32 megabyte. Used RAM only 2 megabyte. Committed is 32 megabyte, and maximum is 2 gigabyte. So I press a button, and in a second, we will get a load. So now the data is different. You can see used RAM is about 1 gigabyte, committed is about 1.2 gigabyte, and maximum stays the same. Let's wait for a little time. Now you can see actually RAM was uncommitted. So committed RAM now is only 32 megabyte. I did nothing. And JVM just uncommitted this automatically. So you can see it's happened automatically. Now let's run the same test, but without these options. Let me clear the screen. Yep. So run the same test. 2 gigabyte of XMX minus jar up.jar 1. So we see in a minute committed RAM only 34 megabyte and used only 3 megabyte. Maximum is 2 gigabyte. I press enter to generate the load. And in a second, we see committed RAM is like more than 1 gigabyte and used is about 1 gigabyte. And we will leave it for a minute, and you will see in time that JVM does not release it back. So it will stay for a long time. So it's not very efficient. And we can check it on statistic, by the way, how it looks at the end. So if we go to our flexible container, right, I will show only RAM. So we had a small spike, and then RAM was returned back to operation system. If we go to fixed RAM, you see, like it's consuming RAM, and it will continue to consume the RAM. So before I did a test, before our demo, you can see it just keeps consuming the RAM. It doesn't release it back. So with pay-per-use model, you will always pay for used resources. So you will always pay for this like big used green line. When Java is flexible, you will pay only for small amount of used resources. This is how, let's say, OpenJDK 12 works. Let's examine Shenandoah, which I like very much. So same, I downloaded application before. No, sorry, I missed. Yeah, it's a new test. Yeah, this one. Yeah. Yeah, let's see what we have inside. So we have this app.jar. test application. So I run the following commands. 2 GB for XMX. I unlock experimental VM options. I define use Shenandoah garbage collector and specify heuristic as a compact. Press button. In a second, we will see initial used RAM 3 MB, committed 3 MB. I press button to enter to generate the load. In a second, we will see used 1 GB, committed about 1 GB as well. And in about 10 seconds, I believe, Shenandoah will release unused RAM back to operation system. You can tune the parameters for Shenandoah as well. If you follow to main page of Shenandoah, you will find additional options where you can specify specific, let's say, periods to uncommit RAM back to OS. But now with my parameters, it's enough already. As you can see, JVM released unused RAM and committed RAM only 3 MB. It returned it back to the initial state. Very good. So it proves that Java can be elastic now. If we go to, let's say, same Shenandoah, but in different container and run it without compact parameter, right? So what will happen? What will happen? Actually, we will get the load again, but load will not go immediately. So it will stay like maybe for an hour. But Shenandoah is smart enough; it will figure out at the end that okay, like looks like there is no load on the system and there is unused RAM. Maybe it's a good idea to return it back. So just to emphasize, Shenandoah is very well advanced, let's say, for vertical scaling. Good. So that was, in short, my demo. Any questions so far?
Nope, no questions so far.
Okay, good. Yeah. So coming back to our old school JVM, you see, like it just does not release back memory to operating system. Okay. So at the end, what I would like to say, keep tracking your memory usage because memory can be not only inside heap, it can be outside of heap. There is a good another parameter like native memory tracking. So you can check where is your memory and improve usage. Yeah. That was in short about elasticity inside containers, inside cloud. I hope again, like this improvement will make life of startups and many customers, many end users, better because it will save money, more resources for internal needs, or just use resources for bigger number of projects on the same infrastructure. And in the world of microservices, I believe it's very important because now you don't have only one virtual machine, right? You run many containers inside virtual machines or on top of bare metal. And if you scale your inefficiency horizontally, you just lose a lot of resources. So it's not good. Moreover, serverless approach gets to the market with pay-per-use model. I hope we will see more and more cloud vendors who offer this advanced pay-per-use model. So, and Java is ready for this now. If you can, please contribute your feedback or contribute even your work, and let's make Java even better. That's it, I believe. In short, if you have questions, maybe you have questions out there.
I was about to ask you about serverless, but you just answered my question. So
Yeah, yeah, because people usually ask about this, like serverless, like what do you think about ground VM? You know, like about all these new movements. It's very good. I believe again, like it provides more options for developers to start easier, to start cheaper. You know, less efforts, more focus on business logic. I do believe it's very good. While we should not forget about the people call like traditional applications. We develop a lot of knowledge there. A lot of applications are running in, let's say, in a traditional way. Yeah. So
I'm sorry. No,
yeah.
there's a question here from Raga. Is asking apart from elasticity, how Jelastic is different from other cloud vendors?
In terms of elasticity.
Yeah.
Okay. Look, we called Jelastic because Java Elastic. We put this elasticity as the core of our solution. So if I switch back quickly to the demo, one of the key advantages I showed you, if you go to, let's say, traditional vendors like cloud vendors, to VPS or to, let's say, even Amazon and others, you order virtual machine, you will always pay for the limit of your virtual machine. Let's say like for 2 GB of RAM. While with Jelastic, only for real used resources. Take a look at the difference. Here, one container has 2 GB of RAM, but Java consumes all. The difference is huge. It means at the end, what you can do, you don't need to afraid anymore the limits. You don't need to think about limits anymore because you don't pay for the limits. So it solves right sizing problem. You know, like when you start the project, you don't know how much resources you need in advance. For example, here, I can put like 10 GB for my virtual machine, sorry, for my container. And I don't care because like I will never pay like for these resources if I don't use them. Yeah, we will wait for a minute and we will get new limits soon. So again, like it solves right sizing problem. You don't need to think in advance. Then if you host multiple containers, your efficiency increases because you can share unused resources. Yeah, that's one of the major differences. So Jelastic is scalable in both directions, horizontally and vertically, which is unique offer today on the market. And in addition, as we love Java very much, we developed a specific auto clustering solution for Java EE. As you know, like to build a cluster with Glassfish, it's not an easy task. You need to know how to do this. Like, and when you add a new node, you need to do manual work, or you need to have a specific automation scripts. Yeah, with Jelastic, you just press a button, auto clustering, and that's it. So Jelastic will create a cluster for you and connect all these nodes to a cluster. Yeah, let's create a Glassfish cluster. So it saves a lot of resources. I mean, human resources and compute resources. Yeah, let's create this one. While it's creating, I will come back to our OpenJDK, and now let's check the limits. So as you can see, altogether, two containers can the limits for them like 20 GB, but real usage is only 1 GB. So the scale range is huge. It's like 20 times already you can scale horizontally. Why it's good? Because if your application is not scalable horizontally, you can get benefits from vertical scaling. Maybe from the beginning, like you don't even need to implement horizontal scaling. Of course, it's good. Horizontal scaling is amazing. We don't need to, you know, like to underestimate the importance of horizontal scaling. But still, like every solution should fit to a specific need and a specific time. If you're developing something simple, like it's not production critical application, like I don't care really. Like I just want to get faster to process my jobs. I hope I answered the question.
Yeah, I think so. There's another question from Evaldo. He asked, what's the principal advantage to use Jelastic JVM compared to other tools?
What is Elastic JVM? Look, Jelastic does not build JVMs, so because we don't offer any like proprietary like JDK or something like this. Like we were working on standard builds, JDK and OpenJDK, and we committed our work to mainstream. So now it's available for everyone. It's not only inside Jelastic, so you can benefit and enjoy elasticity of JVM in any cloud now. So even more, as I mentioned, there are other implementations on the market available, like Shenandoah, ZGC, OpenG9. So you can benefit from this. There is no specific build inside Jelastic. There is no proprietary solution. We only have some proprietary solution for old JVMs. Let's say they do not support this parameter. So we check the version, and if it's old version, we enable our agent that controls the usage and force returning back unused memory. So just again, like to save money for end users. Yeah, but in general, like the benefits of Jelastic, it's doesn't force to use any proprietary solution. We support different kind of JVMs. Yeah, I will show again quick demo. Yeah, quick demo. So you go to environment, right, and you choose different kind of application servers, different versions, and even you can choose different JDK solutions for this Tomcat. So it can help you to test different combinations easily. You don't need to worry like, okay, how to create this Tomcat, like, and how to, download and configure and how to repeat it again. I need to repeat every time I create development environment. Why? People did it already many times. It's easy to automate. It's automated. Just press buttons and get it, or just call APIs. That's in short, related specifically to Java Elasticity. It's not only for Java. We love any kind of languages, honestly. Like, so there is no religion specifically for Java. Like, we have a lot of great end customers who use PHP, Ruby, Node.js, Python, Go, just pure Docker or Kubernetes. People have different preferences, and you need to choose technology that fits the best to your current task. But the worst thing was that Java was not as flexible, let's say, as PHP, because PHP was scalable horizontally, and Node.js is scalable horizontally. Ruby is vertically. Ruby is scalable vertically as well. Java was not, and it was very big issue. Now it's solved. The problem is solved, and I'm so happy that we contributed to this work. I hope I answered the question.
Yeah, I believe so. And there's no more question. And well, it was awesome. Thank you, Ruslan.
Thank you, Elder. Thank you very much.
It was great to have you here. Just starting our series, and I believe that we started really well. Thank you very much.
No problem. As a conclusion, enjoy the elasticity. It's available in any cloud. Try it. If you face any issues, feel free to send me a message. You can easily find me in social media. I'm a very open person. I'm happy to to collaborate, to discuss any difficulties or any ideas. And second, please dream bigger. One guy can change a lot. You can do what you like the most, and you can deliver very good result useful for other people. So don't be afraid. Dream bigger, but take actions.
Awesome. Really
Thank you
great.
very much.
Well, thank you guys. Hope you enjoyed. You can subscribe to the series Java at Cloud Age at bit.ly/Java Cloud Age, so you can spread the news. I will send to guys who can't join us today the replay of this video, and all these videos will be available at SoJava YouTube channel, so you can subscribe and follow the others webinars. Okay, so thank you very much and see you next time. Bye bye. See you
Thank you.
guys.
Bye-bye, guys.